limit as x goes to 1 of 1 minus x squared over x squared minus 4x plus 3. The first thing we're going to do is try plugging 1 in for the x's. In the numerator we'll have 1 minus 1 squared. In the denominator 1 squared minus 4 times 1 plus 3. In the numerator 1 times minus 1 squared, which is a 1. In the denominator 1 squared, which is a 1, minus 4 times 1, which is a negative 4, plus a 3. In the numerator, 1 minus 1 is a 0. In the denominator, 1 minus 4 is a negative 3 plus 3, and that's a 0. We have the 0 over 0 indeterminate form, and it needs to be reworked. Since these are power functions, we're going to try the factor and cancel method. So we will have limit as x goes to 1 of the numerator. It's a difference of squares. It'll factor into a 1 plus x and a 1 minus x. In the denominator, it's a trinomial factoring. We need two numbers that multiply to be a positive 3 but add to be a negative 4. So they're going to both need to be negative for that to happen. And it sounds like negative 3 and negative 1 will take care of that. All right, now that we factored it, we can see the two factors that are making the zeros. In the numerator, it's a 1 minus x. In the denominator, it's an x minus 1. They're opposite sides of each other, so they can't cancel just yet. But if I factor a negative 1 out of one of them, we can then get them to cancel. I'm going to opt to factor out the numerator now. Since there's already another term there, I'm just going to put it in front of both of these terms that are multiplying each other. But I'm factoring out of the second one. It's going to change the x to be a positive x and the 1 to be a negative 1. And it just sits out in front of the entire expression, as you see there. Now by doing that, the x minus 1s can now actually cancel with each other. And we can retry plugging the 1 in at this point. We're going to have negative 1 plus 1 over 1 minus 3, which is giving me a negative 2 over a negative 2. Negative 2 over negative 2 is a positive 1.